Welcome back, everyone, to today's explainer on advanced data modeling. If you've been following our sessions on software engineering and database design, you already know the basics of the entity relationship model. But as you've probably guessed, as our databases grow larger and way more complex, mapping out real-world scenarios requires some heavier lifting. The basic model just doesn't cut it anymore. Today, we're going to fix that by exploring exactly how we handle these advanced, complex groupings. Here is our roadmap for today's session. First, an intro to EERM. Second, supertypes and subtypes. Third, inheritance and discriminators. Fourth, disjoint versus overlapping constraints. Fifth, completeness and approaches. And finally, a summary and exam review. Let's jump right in. Section 1. Intro to EERM. Let's tackle that big question right out of the gate. Why exactly isn't the basic ER model enough for complex applications? Well, the answer is the Extended Entity Relationship Model, or EERM. Sometimes you'll hear it called the Enhanced Entity Relationship Model. Basically, the EERM is the result of adding more semantic constructs to our original ER model. You see, as application software requirements become stricter and more demanding, we desperately need a way to capture highly specific information in our data model. The EERM gives us the tools to do just that. Things like entity supertypes, entity subtypes, and entity clustering. When we sketch this all out graphically, we call it an EER diagram, or EERD for short. But what do these new constructs actually do in practice? Let's take a look. That brings us to Section 2, Supertypes and Subtypes. This is all about grouping unique characteristics, and these are the core tools we use to categorize our data more effectively. Let's define these terms clearly, as you'll be using them a lot. An entity supertype is a generic entity type that contains the common characteristics of its entity subtypes. On the flip side, an entity subtype is a subset of that supertype. It contains the unique characteristics that belong exclusively to that specific subset. Think of the supertype as a massive, broad umbrella, and the subtypes as the highly specific items standing directly underneath it. To really wrap our heads around this, let's walk through an example directly from our textbook. An aviation company. Imagine this company employs pilots, mechanics, secretaries, and accountants. Now, all these employees share certain basic characteristics, right? They all have a last name, a hire date, an employee number. But a whole lot of characteristics are not shared. For instance, only pilots have flight hour restrictions and specific pilot licenses. Only mechanics have aviation maintenance certifications. If we try to just shove every single employee into one massive employee table, we are creating a major database design flaw. We'd literally have to add columns for flight hours and mechanical certifications. And for every single accountant or secretary we hire, those columns would be left completely blank. We'd end up with millions of null values and just a sea of needless dummy entries. And this setup brilliantly illustrates our solution. We can have an employee table acting as our supertype. It holds the shared attributes, like those names and hire dates, for absolutely everyone. Then we can have a pilot table acting as our subtype. It holds only the unique attributes relevant to pilots, like their specific licenses and ratings. By breaking it out like this, we completely avoid all those wasted null values. Now, there are rules for creating a subtype. First, it has to be a distinct, identifiable kind of entity. Second, it must have unique attributes. For example, an accountant is a perfectly valid subtype because they have unique accounting attributes. But a general clerk might not be a valid subtype if they don't actually have any specific attributes beyond the basic employee details. The way we arrange these supertypes and subtypes is called a specialization hierarchy. This is simply a top-down process where we identify lower-level, more specific entity subtypes from a higher-level entity supertype. It's all about grouping unique characteristics and relationships together in a structured, logical way that keeps our database running smoothly. Now that we know what supertypes and subtypes actually are, we're moving to Section 3, Inheritance and Discriminators. Let's look at the mechanical rules of the EERM game that make this hierarchy function. If you've done any object-oriented programming, this next concept will sound very familiar. Our database model uses a concept called inheritance. Inheritance is the property that enables an entity subtype to automatically inherit all the attributes and relationships of the entity supertype. So, our pilot subtype automatically inherits the employee number, the last name, and the hire date from the employee supertype without us having to duplicate that data. Okay, listen up, because I cannot emphasize this enough. If you take away just one mechanical rule from today's explainer, please let it be this. The subtype must inherit the primary key of the supertype. This is absolutely vital. In our aviation example, if the employee supertype uses employee number as its primary key, the pilot subtype must also use that exact same employee number as its primary key. This shared key is literally how the database links the two tables together. So you might be wondering, if we have an employee, how does the database actually know if they are a pilot, a mechanic, or an accountant? Well, it uses something called a subtype discriminator. This is a specific attribute, a column, inside the supertype entity that explicitly determines which entity subtype each occurrence is related to. Let's look at our aviation example again. Our subtype discriminator might simply be a column called EMP_type. It uses simple equality comparisons to route the data. If the value in EMP_type is P, the database knows to immediately look at the pilot subtype. If it's M, it looks at the mechanic subtype. It's essentially a little signpost pointing to the correct specialized table. And just a quick note, while equality is the default, it doesn't always have to be. We could, in theory, use a discriminator like flight hours, where a value greater than 1500 means pilot in command, and less than 1500 means co-pilot. All right, moving into a major climax of this chapter. Section 4, disjoint versus overlapping constraints. I want to highly flag this as an essential exam focus. You absolutely must know the difference between these two constraints. These constraints define exactly how many subtypes an instance can belong to. First, we have disjoint subtypes, also known as non-overlapping subtypes. This means an instance can appear in only one subtype. On an ER diagram, this is denoted by the letter D inside the category symbol. Think of a charity organization. A member can be a volunteer or they can be paid staff, but they cannot be both. On the flip side, we have overlapping subtypes, denoted by the letter O. This is a condition where an instance can appear in multiple subtypes at the exact same time. For example, at a university, an employee might be a professor and an administrator simultaneously. What's really fascinating here is how we actually implement these overlapping subtypes in the database itself. With this joint subtypes, we only needed one discriminator column, right? Like EMP_type. But for overlapping subtypes, one column isn't enough. We need a separate discriminator attribute for each subtype. Replicating table 5.1 from our textbook, you can clearly see how this works. We have a yes-no column for professor and a separate yes-no column for administrator. If they are Y and Y, it means the employee successfully occupies both roles. If it's N and N, they don't belong to either of these specific subtypes. Let's move along to section 5, completeness and approaches. Specifically, partial versus total completeness. This rule dictates whether every single record in our supertype is forced to be part of a subtype. We essentially have two options here. Partial completeness means that some supertype occurrences might not be members of any subtype at all. In an ER diagram, you'll spot this denoted by a single horizontal line under the category symbol. For instance, maybe we have general office staff who just aren't pilots, mechanics, or accountants. Then we have total completeness, which is denoted by a double horizontal line. This means every single supertype occurrence must be a member of at least one subtype. So if they are an employee, they have to be categorized into one of our specific subtype roles, no exceptions whatsoever. When you sit down to actually design these hierarchies, you can take two different approaches. The first is specialization. This is the top-down approach we've been using with our aviation example. We start with the broad, generic employee and break it down into very specific subtypes. The alternative is generalization. This is a bottom-up process. Here, you might be looking at your data and notice you have separate tables for piano, violin, and guitar. You recognize they share common characteristics, so you extract those commonalities upwards to create a generic string instrument supertype. Both approaches are perfectly valid. It really just depends on how you discover the data structures during your initial analysis. All right, we have covered a massive amount of vital ground today. It's time for Section 6, Summary and Exam Review. Let's pause and recap what you absolutely need to know to make sure you are fully prepared for your tests and practical exams. First up, lock in these absolute critical definitions from Chapter 5. The EERM adds necessary semantic constructs to basic ER models. An entity supertype is your generic entity with shared characteristics, while the entity subtype holds the completely unique characteristics. Please don't forget inheritance. That's the mechanism that automatically passes attributes and relationships down the chain. And finally, the subtype discriminator is that specific attribute in the supertype that acts as a signpost, routing the database to the correct subtype table. Next, I want to hammer home these key exam facts. If you are asked to draw or interpret an ER diagram, remember, the subtype must always inherit the primary key of the supertype. Know your symbols for sure. Disjoint constraints use a D and mean an instance belongs to only one subtype. Overlapping constraints use an O and mean an instance can belong to multiple subtypes. And keep a close eye out for that single line denoting partial completeness versus the double line denoting total completeness. If you master these rules, you will absolutely be able to design highly efficient professional database structures that completely eliminate those frustrating null values. But as you'll quickly learn in software engineering, solving one problem often introduces another. We've talked a lot about primary keys today and how they are inherited. But how do we ensure primary keys are actually selected properly in the first place when these designs get this incredibly complex? Next time, we will dive perfectly into our next topic, entity integrity and the art of selecting primary keys. Until then, review your diagrams, practice drawing your hierarchies, and I'll see you in the next explainer.